Alright, the next topic that we're going to start is calculus. It is a very important topic in your class 2 of mathematics. It contains 44 marks as a whole in your class 2 of mathematics. So under this calculus, there are 5 topics. The first one is continuity and differentiability. The next one, application of derivative, integrals, application of integrals, and differential equation. In short, if you don't know continuity and differentiability, you can't do application of derivative, nor you can do integrals, and so goes on. A basic hint about your calculus you have studied in your class 11 also, that is about limits. And I would suggest you, before you go further onto this topic, that's calculus, please go ahead with your limits in for class 11 mathematics. Otherwise, you will be a little bit stuck over here. Okay, let us do the first topic under calculus. That's your continuity and differentiability. That is nothing more than your chapter 5 on the topic calculus. Okay, before I begin with this topic, in your class 11 you got the topic limits, which is very much essential while discussing about continuous. So I want you to go through that topic before you go further on with the chapter 5, right? Okay, so let us take any function. So let that function f of x is equal to 1 if x is less than or equal to 0, and 2 if x is greater than 0. I'm taking any function. So let us draw the function on a graph. So if I happen to draw this function on a graph, it will be your x, this will be your y, your x dash, and your y dash. Now, if you can look over here, the first one is given that x is less than or equal to 0. That means whenever the value of x is equal to or less than 0, then the value of x would be what? 1. So in short, in your graph, the value would be somewhere here. So that's your 1. Similarly, when x happens to be greater than 0, then the value for f of x would be how much? 2. Remember, it's not equal to 0, so I'll just give a dot over here and use a line over here. I hope you're clear with the graph. Now, before I go further, if you can look over here, if x happens to be minus 0.01, now you tell me minus 0.01 lies where? It lies over to the first one because x is less than or equal to 0. That means your limit of x tends to 0 minus would be nothing more than how much? The value is 1. Sorry, f of x. Alright, similarly, limit of x tends to 0 plus f of x would be how much? The 0 plus indicates that the value for x is how much? Greater than 0. 2. Are they equal? Limit of x tends to 0 minus f of x not equal to limit of x tends to 0 plus f of x. They are not equal, right? But according to your continuous, short form for continuous CTS, according to continuous, the limit x tends to 0 minus f of x should always be equal to your limit of x tends to 0 plus f of x. Okay, or you can also see over here that if you can look over here in the graph carefully, now you tell me, can I sketch the graph, can I sketch the graph without lifting my pen? I don't think so, right? Yeah. So as a remark, you can say that the graph of the continuous function can be drawn without raising your pen from the paper. So if you can draw any graph without raising your pen from the paper, that means it's continuous. But if you look over here at the graph, I cannot sketch the graph without lifting my pen, right? So therefore it's not continuous. I hope you're clear till there. Okay, the first one, I hope you're clear. In order to make it continuous, your left hand limit should be equal to your right hand limit. All right, you can pause the video and then see once again if you're not clear. Now let me go with another one, because you are clear again till there that in order to be continuous, your left hand limit should be equal to your right hand limit. So again, let me go with another example. So again, the same function, that f of x is equal to 1 if x not equal to 0, and 2 if x is equal to 0. Now again, let me draw the graph for this function. So if I happen to draw the graph, same thing. So first one will be your x dash, your y-axis, y dash. Now if you can look at the over here, the graph is given that x not equal to 0 and the value is how much? 1. So that means whenever the value comes there not equal to 0, then the value would be 1 on both the side. And when x is equal to 0, the value is how much? 2. This value is 2. So from this graph we are clear that that your limit x tends to 0 minus your f of x is equal to your limit x tends to 0 plus f of x. So which satisfy the condition that your left hand limit is equal to your right limit, so it is continuous. But if you can look over here, your f of 0, that means when x happens to be 0, the value is how much? 2. And these two values how much? 1. Are they equal? No again, right? So that is, from here it's clear that limit of x tends to 0 minus f of x is equal to limit of x tends to 0 plus f of x, but not equal to f of 0. So it is not continuous again. In short, or as a whole, I can say that in order to be continuous, one more condition arises. That means the answer should be here, limit of, not limit, sorry, your f of 0. This whole thing. This whole thing. Alright, so mathematically, it will be popping up at your video right now that for a continuity of a point, a function f of x is said to be continuous at a point a of its domain if limit of x tends to a plus f of x is equal to limit of x tends to a minus f of x is equal to your f of a. Okay, so over here your a happens to be how much? 0 minus 0 plus 0. Okay, so a is over here, your a is how much? 0. And if by any means you got your left hand limit not equal to the right hand limit, or same thing over here, you got the left hand limit is equal to your right hand limit but not equal to your f of 0, that means the function is discontinuous. I hope you're clear till there. Okay, so graphically for continuous, and discontinuous, sorry, for continuous, your diagram should be a diagram where you cannot lift your pen. So I don't have to lift my pen. Suppose I circle, or suppose I say a straight line, or suppose I say a curve. So these are all continuous, and discontinuous will be somehow like this. Suppose you go at point and you're stuck over here. See, they're not meeting. Similarly, line, stuck. If you can just look over here, after drawing this, I have to lift my pen, and then this one. And for a curve, same thing. From here, the graph will be somehow like this for discontinuous. For continuous, it will be a smooth graph where you don't have to raise any paper. Alright, some of the theorems will be popping up right now. The first theorem is given that every polynomial function is continuous. Second theorem is given every rational function is also continuous. The third is given that every continuous function is continuous. Sorry, every constant function is continuous. the fourth is given that the identity function is continuous, and fifth, which is very much important, is given that suppose f and g be two real function continuous at a real number c, then f plus g is continuous at x is equal to c, f minus g is continuous at x is equal to c, f dash g is continuous at x is equal to c, and f by g is continuous at x is equal to c, provided g of c not equal to 0. These are some important theorems. Alright, these theorems have been proven at your textbook. You just have to search at your textbook. Over there it's not given theorem, it's given as an exercise only. So this was the explanation. If you're not clear, just pause the video whenever you want and just simply look over again and again, okay? Alright, let us do some exercise. Exercise 5.1. Question number 1 is given that prove that the function f of x is equal to fx minus 3 is continuous at x is equal to 0, at x is equal to minus 3, and at x is equal to 5. Okay, now by looking at the equation, just see the equation, this one. F of x is equal to 5x minus 3. Tell me whether it is continuous or not. Forget about the point right now. This 3 point, just ignore this point. Check. Your 5x minus 3 is what? A linear equation. Yes or no? And if it's a linear equation, it will be what again? It will be a polynomial. Right? And if you can see over there at the theorem number 1 is given that every polynomial function is continuous. So in short, at every point this will be continuous only. Okay, so you don't have to solve because we know that a polynomial function is continuous, so you can just run this continuous. But if you have to solve, how will you solve? Let me just do it over there. So it's given that your f of x to be that, so let me just do x is equal to 0. So it will be limit of x tends to 0 minus f of x is equal to limit of, now it's x tends to 0 minus, so it will be h tends to 0 f of 0 minus h. Are you clear? Or you're not? See, if you're not clear, that means you haven't gone through your class 11 limits. If you're clear, that means you've gone through. Very good. Alright, so the next thing would be limit of h tends to 0. 0 minus h will be how much? F of minus h. Now, in place of x, I'm getting how much? Minus h. So it will be limit of h tends to 0, 5 of minus h minus 3. So which will be 5 into 0 minus 3 is equal to minus 3. Because your h is how much? 0. That was your 0 minus left-hand limit. So similarly, let me do the right limit. Limit of x tends to 0 plus your f of x, which would be limit of h tends to 0 f of 0 plus h. Now look here. Here was plus. That's why it happened to be plus. So which would be limit of h tends to 0 f of plus. Again the same thing. Limit of h tends to 0. In place of x, I'm getting h. So that will be 5 of h minus 3. So the same thing. 5 into 0 minus 3, which is minus 3. Also, your f of 0 would be f of 0 would be 5 into 0 minus 3, which is minus 3. So I can say that your limit of x tends to 0 minus f of x is equal to limit of x tends to 0 plus f of x is equal to your f of 0. So it is satisfying every condition of a continuous. So therefore it is continuous at x is equal to 0. Alright, I got at x is equal to 0. Now similarly, do it for x is equal to minus 3 and x is equal to 3 in a similar way. The one I have done. Okay, alright, let me jump to the next question. That's question number 2. It's given that examine the continuity of the function at f of x is equal to 2x squared minus 1 at x is equal to 3. So here again the same thing. So first one will be limit of x tends to 3 minus your f of x, which would be limit of h tends to 0 f of 3 minus h equal to limit of h tends to 0. Now in place of x, I'm getting how much? 3 minus h. So that will be 2 3 minus h the whole thing square minus 1. So which would be I have to expand this one. Okay, so how to expand this one? By using formula a minus b the whole thing square. So which will be limit of h tends to 0 to, so that will be 9 minus 6h plus h square minus 1. Now h is how much? 0. So if I put a value for h to be 0 over here, I'll get the answer 2 into 9 minus 1, which is 17. So that was for your left hand limit. Now similarly do the left hand limit of x tends to 3 plus your f of x in a similar manner. So limit of h tends to 0, f of 3 plus h is equal to limit of h tends to 0, 2 of 3 plus h the whole thing square minus 1, so which would be limit of h tends to 0. Now I have to use formula a plus b the whole thing square, so 2, that will be 9 plus 6h plus your h square minus 1, so which would be 2 into 9 minus 1, again 17. I got the same answer. So lastly your f of 3 would be 2 into 3 square minus 1, which is 2 into 9 minus 1, again 17. Now if you can see, all the three terms happen to be same, and that is I got here 17, 17, 17. So I can say that, so that is limit of x tends to 3 minus your f of x is equal to limit of x tends to 3 plus f of x is equal to your f of 3. So therefore it is continuous at x is equal to 3. Alright, I hope you're clear until there. So you can do the next question by yourself. Let me just jump to your question number 6. Alright, so question number 6. Question number 6 is given that the point your f of x is given to be 2x plus 3, 2x minus 3. So if x is less than or equal to 2, if x is greater than 2. So it's given. Okay, by looking at the question, just look at the question and then tell me whether it will be continuous or not. You can see it as a polynomial function, right? So it should be continuous. Yes or no? Let's try and then see whether it's continuous or not. Okay, so it will be because the point is at 2, so at x is equal to 2, let me just go with the left hand limit first. Limit of x tends to 2 minus f of x would be limit of h tends to 0, f of 2 minus h, which will be limit of h tends to 0. Now for 2 minus, it means the value for x is how much? Less than 2, because it's 2 minus, obviously it will be less than 2. Yes or no? So your f of 2 minus h will be how much? 2. In place of x, I'm getting this one. So in place of this x, I'm getting 2 minus h. So it will be 2 minus h plus 3. So put the value for h, so it will be 2 minus 0 plus 3, which happens to be 4 plus 3. 7. That was for your 2 minus. Let us do for 2 plus. So limit of x tends to 2 plus f of x. Again in a similar manner, limit of h tends to 0, f of 2 plus h. So 2 plus h, it means now it's greater than 2. Greater than 2 means I have to take this value. So that will be limit of h tends to 0, 2 plus h minus 3. So that will be, because the value for h is how much? 0, so 2 plus 0 is 2, 2 2s are 4, so it will be 4 minus 3, which is 1. Now, I'm sorry, that's 1. Now if you look over here, the value doesn't match of the left hand limit and right hand limit, because your left hand limit you got to be answer to be 7, and right hand limit you got the answer to be 1. So that is limit x tends to 2 minus f of x not equal to limit x tends to 2 plus f of x. So it is discontinuous. I hope you're clear. Okay, the next question is question 7. Okay, if you look at the question 7, one very interesting thing is over here. That's this one. This is your modulus. Now, according to the definition of modulus, that is, when is f of x is equal to modulus of x, two things arises. The answer would be x if x is greater than or equal to 0, and minus x if x is less than 0. This is the definition for your what function? That's your modulus function. Now, if you look at question 7, for the first term is given that x less than or equal to minus 3. So in short, can I do this question in this manner? Minus x plus 3 if x less than minus 3, minus 2x if minus 3, and 6x plus 2 if x is greater than or equal to 3. Are clear? Why? Look at the modulus is given that if x is less than 0, the value is how much? Minus x. I got how much here? Less than 0 or not? Minus 3 is less than 0. That's why I'm just writing minus. Okay, now if you look over here, now it's this question. What are the things that arises? Two things. That's minus 3 and then plus 3. So I'm going to do it for two different points. So the first one would be at x is equal to minus 3. So limit of x tends to minus 3 minus f of x would be equal to limit of h tends to 0 f of minus 3 minus h. Minus 3 minus, it means it's less than minus 3, the first value. So which would be limit of h tends to 0 f of minus 3. Now I'm doing the same thing, sorry. So in place of x, it's how much? Minus 3 minus h. So it will be minus 3 minus h, minus is there, remember, plus 3. So which would be, if I put a value for h to be 0, minus and minus plus, so 3 plus 3, that's nothing more than 6. I hope you're clear. And also the next one will be limit of x tends to minus 3 plus f of x, which will be equal to limit of h tends to 0 f of minus 3 plus h, which will be equal to limit of h tends to 0. Now it's minus 3 plus. Minus 3 plus means x is greater than minus 3. So x greater than minus 3, the value is minus 2x. So which would be minus 2 minus 3 plus h. But the value for h is how much? 0. So which would be minus 2 minus 3 plus 0. So which is 6 again. So I got left hand limit and right hand limit to be same, 6, 6. Now let's do for f of minus 3. So when f happens to be minus 3, that means it's equal to minus 3. Equal to minus 3, it will be how much? The first one, that is minus x plus 3. So which would be minus of minus 3 plus 3, nothing more than 3 plus 3, which is 6. So I can say that it is continuous. Continuous at x is equal to minus 3. Alright, now similarly let us do for at x is equal to 3. You can pause the video and then see once again, okay, before we go for x is equal to 3 if you didn't understand. So let me just go for x is equal to 3. The answer will be this. So the answer will be not continuous at x is equal to 3, which is discontinuous. Why? Because I got your right hand limit to be 20 and your left hand limit to be minus 6. So right hand limit not equal to left hand limit, so it is discontinuous. Okay, let's do question number 13. It's given that is the function defined by f of x is equal to x plus 5 for x less than or equal to 1, x minus 5 for x greater than 1, a continuous function. So we have to prove that whether this function is continuous or not. So the given point is at x is equal to 1. So at x is equal to 1. So let's try to do, first of all, the left hand limit. Limit of x tends to 1 minus your f of x. So it will be limit of h tends to 0, f of 1 minus h. So which would be limit of h tends to 0. So 1 minus, it means it's less than 1. Less than 1, the value is how much? In place of x, I'm getting 1 minus h. It will be 1 minus h plus 5. So h is how much? 0. So it will be 1 plus 5, which is 6. Similarly, limit of x tends to 1 plus f of x is equal to limit of h tends to 0, f of 1 plus h, which will be limit of h tends to 0. Now it's 1 plus. 1 plus means x is greater than 1. So greater than 1, it means it will be 1 plus minus 5. So it's h happens to be 0, 1 minus 5, which is minus 4. In short, your left-hand limit x tends to 1 minus f of x not equal to your right-hand limit. So it is a discontinuous function. Alright, question number 17 now. Okay, the rest of the question you can try by yourself. Same thing, you just have to prove whether it's continuous or discontinuous, same manner. Yeah, question number 17. This type of the questions are very important, and most of the time it's asked at the exam also. Okay, so it's given that find the relationship between a and b so that the function f defined by equation is continuous at x is equal to 3. So in the equation is already given that it is continuous at x is equal to 3. So as the function is continuous at x is equal to 3, so I can say that therefore limit of x tends to 3 minus f of x is equal to limit of x tends to 3 plus f of x is equal to f of 3. That's the definition for your continuous. I hope you're clear until there. Now I just have to put the value, so it will be limit of h tends to 0 f of 3 minus h is equal to limit of h tends to 0 f of 3 plus h is equal to f of 3. That means the value for x is equal to 3 is how much? Ax plus 1. So that will be I'm doing for minus the first one, so that in place of x put the value, so it will be a 3 minus h. I'm forgot to put the limit of h tends to 0 plus 1 is equal to limit of h tends to 0. It's plus means x is greater than 3, so the second value, so that will be b of 3 plus h plus 3 is equal to ax plus 1. So put the value for h, so I'll get here 3a plus 1 is equal to, I'll get here 3b plus 3 is equal to, oh sorry, I totally forgot to do this one. In place of x is how much? 3. Okay, so this should be actually this one, a into 3 plus 1. Ignore this one. Okay, so that should be 3a plus 1. Mistake. After all, I'm also a human being, so human being make mistakes, right? So that will be 3a plus 1. So taking first and second term. So if I take the first and second term, I'll get the answer 3a plus 1 is equal to 3b plus 3. So 3a minus 3b is equal to 3 minus 1. I can take 3 common, so just do it over here. So if I take 3 common, it will be a minus b is equal to 2 by 3. So a is equal to 2 by 3 plus b. So that's your relation. Alright, from question 26 onwards is a very important question. Okay, most of the time they use ask question from 26, 27, 28, 29, 30, where we have to find the value for k. Alright, these type of questions are very important. Question 26 is given that it is continuous. It is continuous at x is equal to pi by 2. So same thing just like the previous one, so it will be limit of x tends to pi by 2 minus f of x is equal to limit of x tends to pi by 2 plus f of x is equal to f of pi by 2. So pi by 2 minus would be limit of h tends to 0 f of pi by 2 minus h is equal to limit of h tends to 0 f of pi by 2 plus h is equal to your f of pi by 2 happens to how much? 3. So expand. Now if you look over here, in place of x I'm getting how much? Pi by 2 minus h. So that will be, look at here very carefully, okay? The value for h is how much? 0, remember that. So that will be limit of h tends to 0 k cos pi by 2 minus minus h divided by pi minus 2 pi by 2 minus h is equal to limit of h tends to 0, same thing, it will be k cos pi by 2 plus h divided by pi minus 2 pi by 2 plus h is equal to 3. I guess you are clear till there. Alright, so the next step would be pi by 2 means what degree? 90 degrees. So the answer will be limit of h tends to 0. K cos 90 minus theta is how much? Sin theta. Divided by, if you just simplify that, I'll get here pi minus pi, so it will be minus minus h. Similarly, limit of h tends to 0. Cos of 90 plus theta is how much? Again, minus sin theta. So divided by, again you'll get here h is equal to 3. You'll get here minus 2. I totally forgot about 2, sorry. I hope you are again clear till there. So after that, it will be, the first one will be k by 2 limit of h tends to 0 sin h divided by h. Similarly, k by 2 limit of h tends to 0 sin h divided by h, because minus minus will be cancelled, is equal to 3. So it will be k by 2 into 1 is equal to k by 2 into 1 is equal to 3. So that will be, that is k by 2 is equal to 3. The value for k is how much? 6. Alright, you just check once again, pause the video and see once again. Alright, let us do question 29 after that. Question 29 is given to be this. Now it is continuous at x is equal to 5, and I have find the value for k. So as it is continuous at x is equal to 5, so therefore your limit of x tends to 5 minus f of x would be equal to limit of x tends to 5 plus f of x equal to your f of 5. Now after that, I'll just ignore this one, okay? Why? Because this and this would be same. Right, I'm just going to first do, okay, let me just do it, it doesn't matter. So it will be limit of h tends to 0, it will be 5 minus h, limit of h tends to 0, f of 5 plus h. Your f of 5 having to be how much? K into 5 plus 1. So 5 minus, it means the first one, because it's less than 5, so that will be limit of h tends to 0, k 5 minus h plus 1. Your 5 plus means the second one, so that will be limit of h tends to 0, 3, 5 plus h minus 5 is equal to 5k plus 1. Just put the value for h, you will get here 5k plus 1. Put the value for h, you will get here 15 minus 5 is equal to 5k plus 1. So that is 5k plus 1. The 5k plus 1 would be equal to how much? 10. Right. So your 5k would be 9. So k would be 9 by 5.